The problem statement from GATE Physics 2019 paper reads as follows. For the following circuit, what is the magnitude of V out if V in equal to 1.5 volts? We are given with a circuit with operational amplifier and a few resistors, and we are given 4 options and we have to choose the correct one. Before solving any problem, we need to ask ourselves a few questions. First, is this op amp ideal? Now the question does not say anything about it. If the question does not say anything whether the op amp is ideal or not, we assume it to be ideal. If it's a real op amp, the question must say it. Second, we ask if there is any feedback or not. So how to check it? From V out, if you can reach some to any of the inputs, whether inverting or non-inverting, there is a feedback. So using this 100R resistor, this is called a feedback resistor, the output can be fed to the input. Hence, we conclude there is a feedback. What kind of feedback? So if the output terminal is connected to the inverting terminal, we call it a negative feedback, which is the case here. Now, in such scenarios, in ideal op amp, we assume the input current to be 0 because this is an ideal op amp. Now, this is a very interesting situation happens. So, redraw the circuit here. So, the input current here is 0, right? Let me choose a different pen. Okay. Remember that there is an Rin here. This is Rin, right? So, if I apply Ohm's law across this Rin, I can say, write V plus minus V minus equal to Rn times 0. Remember that Rn is usually a very high value, mega ohms or something like that. So why 0? Because current, there is no current flowing here. So I get V plus minus V minus equal to 0. This implies V plus equal to V minus. So what's happening is that this voltage is exactly the same as this voltage. This condition is called virtual short. Note that they are not actually shorted. They're not shorted, but it's as if they are shorted. What this means is that we denote it by a dotted line like this. But what it means is that the potential at the inverting terminal here will be exactly the same as the non-inverting terminal. So let's assume the potential here is Vx at the inverting terminal, right? So we can simply say, due to the virtual short condition, Vx equal to 0 volts because the potential here is 0. Due to virtual short. Now, we are required to find what's the value of V out. So if we find the current, we'll be fine. So let's assume a current I is flowing through this resistor here. Now, there's no current flowing through here. If we use if we apply KCL at this node, so KCL at inverting terminal. So let's call this current IF. So I can write I plus 0 equal to IF. This implies IF equal to I. So what's happening is that since there's no current flowing through here, all the current which is flowing through this resistor must flow through this resistor. Very simple. Now we apply Ohm's law across the resistor R. So we apply Ohm's law across R. So what's the potential drop across R? It's V in minus Vx. This is the potential Vx equal to current flowing through that is I times the value of resistor is R. So we get the value of I as V in minus the value of Vx is 0. V in minus 0 upon R. Now let's apply now Ohm's law across 100R, the other resistor that we have in the circuit, this resistor. So again I'll write the potential drop, so that is Vx minus V out, the potential drop across 100R equal to current flowing through that is IF times 100R. So what I'll get is that now Vx is 0 and IF equal to I. So I again get IF equal to I, which is equal to minus V out upon 100R. Now if equal to I, so I'll equate these two expressions and I'll write it here. So I'll write V in upon R equal to minus V out upon 100 R. So this will give me V out equal to minus 100 times V in, and we know the value of V in, which is 1.5 volts. So minus 100 times 1.5, we get minus 150 volts. Very good. So we get minus 150 volts as the value of V out. But note that we cannot go beyond plus 15 or minus 15 volts because this is the maximum value that we can achieve, right? So even though theoretically we have obtained it's minus 1, it can go up to minus 150 volts, but it will get saturated at minus 15 volts. So the option here would be C. Actually, technically it should be minus 15, but this is the most correct option. So we'll choose the option for V out as minus 15 volts, which is option C. Yeah, that's it. Thank you for listening.